Hey everybody, welcome back to another video. Today, I am using OBS for the first time. So far, it's been very intuitive. I've been able to edit everything the way I want to and adjust the scenes that I want. So this is a test run. Hopefully it goes well. But today, we're going to be trying Let's Get There Slowly by Sujoyku. I believe this was rated as a 2-star on Logic Masters. I wanted to try it out. See if these rules are comprehensible to me and if I can even solve this. So we have normal Sudoku rules apply. Each row, column, and 3x3 box has to contain the digits 1 from 9 once each. So those are just some examples that I'm highlighting. And then the regionometer box borders divide the blue line into segments whose sums must strictly decrease from one end to the other. If the line enters a box more than once, each segment is considered separately, and in which direction it decreases is to be determined by the solver. So let's say it started decreasing from this end. So this would be smaller than this, right? This 5-cell segment would be smaller than this 2-cell one. Each segment is considered separately. Okay. Little killer digits on a marked diagonal must sum to the clue outside the grid. So this diagonal must add to 30. Whoops. This diagonal must add to 10. Okay. And that's it. Wow. All right. Well, let's see. Decreasing from one segment to the next. Okay, so minimums and maximums might be the best way to think about this. So this, I feel like it'd be very difficult for this to be the high end because its maximum is not very high. This maximum is much larger in box 1. So I feel like this, just looking at it, this is more likely to be the high end, and then it decreases from here. But could argue it decreases from here as well. Not sure. Because you could go, I mean, the maximum 17. You go 16, 15, 14, 13. Well, that can't even be 13. This is a minimum of 15. These 5 cells. Well, that answers our question then. This can't be the high end. Because even if you maximize it, 17, 16, 15, 14, yeah, that cannot be 13. So this is the high end. Okay. High, and then this is the lowest. So the maximum here could be 24, could do 23, 22, 21, 20, 19, 18, 17. Now we know what those are. Well, we don't know, because that's assuming this is 24. But 17, 16, 1, 2, 3, 4, 5. That's pretty close to the minimum of it. 16, 15, 14. So hold on. How high does this have to be? Because it's reaching the upper limit here. I think it has to be 24 or 23. What can we do 23? 23, 22, 21, 20, 19, 18, 17, 16, 15, which is the bare minimum, 14, 13. So this is 24 or 23, because I have a feeling if you start at 22, 22, 21, 20, 19, 18, 17, 16, 15, Yeah, 14. That can't be 14 because the bare minimum of these cells is 15. So this is 23 or 24. And no matter what, it's either 689 or 789. So let's see if I know my keyboard shortcuts. 8 and 9 are for sure in these cells. We just don't know if it's a 6 or a 7 that goes with them. So 24 or 23. Is there a way for me to prove that it's either one? I mean, if it's 23, then we're hitting 15 here. 1, 2, 3, 4, 5. Is that problematic? You know, it could be actually, because, yeah. Okay, so if this, I think it is a problem, because you're using too many digits that are needed to make 13 with these 2 cells and these 5 cells. Because if that's 15, that's 13, because this 14's in between. So if I start from 23, I'll go 22, 21, 20, 19, 18, 17, 16, 15. So let's just say it's like that. Okay, 15, 14, and then 13. But how do I make 13 without using 4 or 5? You can't, because the only ways... Oh, no, 6 and 7. You could do 6 and 7. Oh. And I'm assuming the only way to make 16 is 1, 2, 3, 4, 6. Probably. Yeah. So I wonder if that's more restricting. If it's 24... See, that's the thing, though. If it's 24, it doesn't have to decrease by 1 every single time. I could skip. But then again, this is quite restricting because this is 6 cells. 24, 23, 20. Yeah, what's the minimum of these? 21? Oh, okay, well, that's our answer. That's a much easier way to look at it. This has to be 24, because if it's not, let's say we start at 23. We go 22, 21, 20. But how are you supposed to fit 20 in 6 cells? You can't. The bare minimum is adding up the digits 1 through 6, which adds to 21. 21. Yes, this is 24. Okay. So this is 24. Oops, I don't know the keyboard shortcuts very well yet. How do I do... Is it control? There we go. And then this is 23. It has to decrease by 1 strictly every time, because that's the only way to make this work. To make this be 21. And if it's higher than 21, well, now we have a problem where it's going to basically make this higher than 24, because it has to trace back to something that's higher than it by 3. Yeah. It's like there's this constraint and there's this constraint. And once you figure out which way it decreases, which we figured out very quickly, it makes it a lot easier. So this is 22. Or sorry, 24. This is 23. So these are digits 6, 8, and 9. Okay. 24, 23, this is 22. So this must have a 9. But we don't know if it's 6, 7, or 5, 8. Oops. Oh, shit. We don't know if it's 6, 7, or 5, 8 to get to 13, because there are 2 ways to make 22. 9, 6, 7 or 9, 5, 8. But we know there's 9s. There's probably some sort of triple. I mean, look at all these cells in these 5 cells in column 2. There has to be some sort of quintuple going on there. If this is a 9, or no, if this is a 7, that makes an 8-9 pair. That's a 6. I'd have to think about this more. I don't know what all this overlap means. I guess you could use this little killer in some way. Like, we know these add to 22 plus 10. That's 32. So these 4 cells have to add to 13. Maybe that's decent. Okay. So this is 21. We know it is. So it actually is digits 1, 2, 3, 4, 5, which is very interesting. So the 1, 2, 3, 4, 5, 6, I meant. Let's add 6 onto there. And these are 7, 8, and 9. So this is 21, 20, 19, 18, 17. So we know this is 8, 9, 16, which I think has to be 1, 2, 3, 4, 6. 15, 14. So that's 5, 9, or 6, 8. 16. Oh, but it doesn't have to be. Okay, that's interesting then. That's interesting. Because we know it must decrease by 1, because if it decreases too quickly... Well, actually... Well, let's think about this, actually. I shouldn't act like I'm so sure about what the rest of this segment is. So we know we have to start for 24, and it has to decrease by 1s, because that's the only one to make 20... That's the only way to make 21 work in these 6 cells. Now, does this have to be 20? 1, 2, 3, 4, 5. That's a bare minimum of 15. No, but then again, this is constraining. Right, it's this. It's the later down it goes, the more constricting it is. So this is at least 15, which means this is at least 16. This is at least 17. That's what that means. This is at least 17, but we don't know if it's 20. I just assumed it was 20, but it's at least 17. It's 17, 18, 19, or 20. 17, 16, 15, 14, 13. Oh, no. This is at least 15, so this is at least 16. This is at least 17. This is at least 18. This is at least 19. So now we've got it down to 2 options. It's 19 or 20. But does 19 work? 19, 18, 17, 16, 15. And this is what I was trying to find out earlier, because 15, 14, and then 13, you could still do 6, 7. It's a bit annoying. You could make that work. It's 19 or 20. Doesn't have to include a 1. It almost does. If it's 20, it doesn't have to include a 1, because it could be 2, 3, 4, 5, 6. So... ...15, 16, 17, 18, 19. So wait, 19, 18, 17, 16. This is 16 or 17. Either way, it has a 9. Okay, I should have seen that. And then it's either 7 or 8 with the 9. I don't know which one, though. Maybe I should add 9s in there to not confuse myself. Same here. Add the 9s so I don't confuse myself. Okay. This is 15 or 16, so it must include 1, 2, 3, and 4. I guess I should do this. And then I don't know if the last digit is 5 or 6. We're not sure. So doesn't that limit what this could be? I guess it doesn't. Because as we saw, this does 16 limit things? 1, 2, 3, 4, 6. 16. See, that's the thing. Well, I guess it... 16, 15. Like, who's saying this has to be 15? Is there a way I could say that this can't be something based on what this can be? Because we're noticing that at this end of the line, there are less and less restrictions. But if we start from here, this is either 19 or 20. This is either 18 or 19, 17 or 18, 16 or 17, and so on and so forth, 15 or 16. But then these, I don't know. Because there's no restriction that's happening later on that's restricting what can happen before, because this could be so many things. But I guess it can't have 1 through 4. And it can't be 5 and 6. I mean, these are technically the candidates. If I were to lay them out, it's just digits 5 through 9. Those are the candidates. Can't be both 5 and 6. So I guess the bare minimum of this would be 12. That would be the bare minimum. Because I can't do 11 because I'd be getting rid of both the 5 and 6 that I need for 15 or 16. Yeah, bare minimum's 12. So this is at least 13 then. This is at least 13. This is at least 19. That's 32. These are at least 32. So this is a maximum of 13 between these three cells. I don't know if that helps me. I genuinely don't know. But this is a bare minimum of 12. If I minimize that, I guess the bare minimum here is 28. Can it be? Because then, if it was 28, that'd be 8, 9. That's 7. That's 8 and 9. That's 6. Oh, and that'd be 5, 7. That's 12. And then how am I supposed to get to 22? That's actually interesting. That is exactly what's happening. That's quite nuanced. I'm not sure if that's the way you're supposed to get there, but that's actually... There's sort of a chain happening. Kind of if you start... Okay, so essentially what I'm looking at is I'm seeing... Is this 15 or 16? Essentially is the main question here. Now, I'm going to say it can't be 15, because if it is, in some shape or form, it's... I don't know, it could be something like that. If it's 15... then it doesn't force 8, 9 here, does it? Well, 15. No, it does. That's so weird. Because 15, we're already getting rid of so many candidates. We can't go very small here. So we can't just say, oh, we could go 15, 14, and then 2. And then 7. Well, no, we can't. The bare minimum of this is 13. So putting 15 in here actually does force 13 in here, which forces 14 here. So this would be 13, just like this. And then no matter what, we'd get 8 and 9 in the top right corner if we do 15. But the problem is that forces 7 here, 8, 9 here, a 6 here, and then now all of a sudden we have 5, 7, and that's 12. And how are we to get to 22? That's impossible. So that is the... I don't know if that's how you're supposed to see that, but that's why this can't be 15. It must be 16, which means this is 17. And then, so this is 1, 2, 3, 4, 6. So 16. So 6 can't go in here. So the bare minimum's 12. But then again, we can't have 8 and 9 in the top right corner because it's going to force that bad situation to happen. Oh, so if that's 17, then this is 18, 19. This is 20. 20, 19, 18, 17, 16. Oh, can it... Right, you can't even... I guess you could get to 14, 5 and 9. I suppose you could. What are our options here? I got to consider that. Well, it can't be 12 because then we'd be forcing 8 and 9 in the top right corner, and we know we can't do that. So it's at least 13. 16. This could be 15 or 14. Is it these three cells? This is 22, 21, 20, 19. So we cannot put a 1 on these cells. I know that. These having to add to 30 will somehow be helpful. I'm not sure how. Maybe I should just think about what this cell could be. It seems quite restricting, doesn't it? Because it's going to force a pair to happen and then... Like if it's 7. Right. No, that is the point, isn't it? The whole point was we couldn't have 8, 9 up here. But a different interpretation is you just can't have a 7 here. Because if you do, you get 8, 9, 6, 5, 7, then you got to put a 10 here. That's impossible. So that all stems from this being a 7. You just can't put a 7 there. That's an easy way of thinking about it. So 7 does, in fact, go here. Now these cannot be 7s anymore. Oops. Let's do that. There's like some sort of triple happening here. So it's either 7, 8 or 7, 9. If it's 7, 9, then the 9's here. Then how do you get to 13? We have to do 5 and 8. Yeah. And that's 6. That's fine. Nothing wrong with that. Can we put a 7 here? Then we got to get to 15. Right? 22. Yeah, we got to get to 15. And the only way I could see... Yeah, you got to include a 9. So 6 and 9 would be what that has to be. That'd be an 8. Yeah, and then you'd have double 7. So there's an easier way to do this that I'm just not seeing, but either way, I'm figuring it out. You cannot include a 7 on any of this, because the 7 forces this because there has to be a 9 in this 22 cage. The only way you can get to 22 without repeating a 7 by doing 7 and 8 is to do 6 and 9. But the problem is that forces an 8, and then boom, you can't do this 24 anymore. So 7 can't go, which means we know what this is now. This is 9, 5, 8. So no 6. I could get rid of the 9s in the corner, so that is 5, 8, 9. So, yeah, this is too many shared digits. 5, 6, 7, 8, 9. So this is a 6. If it's anything else, it just screws the whole thing. Is that what I'm seeing? If that's 8... you get 7, 9. You repeat 5. If it's 9, You get 7, 8, cool, but then you get repeat 5. Okay, so this has to be a 6. And then we have a virtual 8, 9 pair between these cells. It is a 5, 7, 8, 9 quadruple, I think. It is. It is. It was a 5, 6, 7, 8, 9 quintuple, essentially, but I just didn't see it the whole time. Okay. So that's a naked 8, 9 pair. Okay. But we already knew 5, 8, and 9 were restricted to those cells. So our candidates then are 1, 2, 3, and 4. 5, 6, yeah. Which, this seems stupid to pencil mark, but the reason why it's actually useful is because of this. Because by virtue of this 10 cage, this is 6, 7, 8, or 9. But it can't be 8 or 9 because of the 8, 9 pair in column 1. So this cannot be 1 or 2. It is 3 or 4. So it's either 3, 7, or 4, 6. Those are the only options. Okay, so that's where the killer helps. All right. I'm not sure where to go from here. There's probably easier ways to go about what I'm doing. 1, 2, 3, 4, 5. I don't think that's going to be useful until later. So we know this is 17, 16. This could be 14. And I got to remember it can't be 12 because then that forces 8, 9, and that cell can't be anything. So it's essentially, it has to include an 8 or a 9. Oh, I see what that's doing then. I see what that's doing then. I think. If it includes an 8 or a 9, isn't this a virtual 8, 9 pair between these 3 cells? That should be what's happening, if it has to include 8 or 9. And regardless of which one it includes, the other one's going to be right here. So this cell cannot be 8 or 9. It has to be 7. I'm pretty sure that's right to say. We'll figure out later if that was a mistake. But I'm pretty sure that's what that means. So these can't be 7s anymore. 7 is up here. So 7 is for sure in one of those 2 cells. So now this is 13 or 14. Which means this is 14 or 15. So we're getting closer to figuring out what the end of this line is. It definitely includes a 5. We know that. And then this includes the other 8 or 9. So there's a virtual 8, 9 pair there as well. 8, 9 pair here, 8, 9 pair here, 8, 9 pair here. There's like all these virtual 8, 9 pairs. Okay. I gotta watch out for that. There's lots of those. So this is 21. This is 20. 19. 18. This seems... it could be difficult. This could be restrictive in some way. 18. Well, I'm not sure. 18 in 5 cells. Is that very restrictive? Hmm. I don't want to start there. Is it these cells that I have to look at? This collection of cells? This big overlap here? Because this overlap was inherently restrictive. I wonder if this one is as well, and I'm just not seeing why. $21, $20. 20 and 5 cells is not very good. I feel like it's this. So 16, 15, 14 or 13, 16, 14, and then you could go 13. $13 or 14, 14 or 15. But we know this, no matter what, is 19. So if it's 19 plus 15, it's 34. These three have to add to 11. If it's 15, if it's 19 plus 14, that's 33. And then these three add to 12. So these add to 11 or 12. I just don't understand what the restriction is. How this helps me. Maybe it's something else. Sorry if you guys can see what I'm supposed to do. I'm just not. Oh, well, there's a naked 789 triple in column 6. That's a fair point. So just 1, 2, 3, 4, 5, 6 chilling in the column. Can't these other cells be 5 as well? I think they can. 1. Oh, no, it was a 5, 7, 8, 9. It was a 5, 6, 7, 8, 9 quintuple in column 2. In other words, there's no way I could put 5 here. I would force 8, 9, yeah. So this cannot be 5. So 5 is in one of these two cells. So this is a 7, 8, 9 triple now. That's an 8, 9 pair now. Okay. $21, $20, $19, $18. $15. I just want to figure it out from here. I just want to see our options here. If it's 5, 8. If it's 5, 9. That's an 8, that's a 9. That's an 8, that's a 9. It's 15, 16, 15. I just don't know. Shoot, I got a Command Z because I don't know where I started this whole thing. Okay, so we did have the 7. You know what? This can't be 7. Because if it was, that force 8, 9 here, and that cell couldn't be anything. So this can't be 7. Just like how we got rid of that 5 in this cell. That's interesting. So 7s must be in one of those 2 cells. So that means that 7s can't be in these. It's a marginal improvement, I guess. Oh, but that forces an 8, 9 pair in column 6, making that a 7. Oh, that's weird. Isn't that weird how that works? Alright, so that is a 7 now. Not sure how that helps me, though. The 8, 9 pairs are only going to do so much. Maybe I could color them. It could be worth it. Let's correspond them to where they land. So the 9 happens to land on blue, and then 8 is yellow. So let's just... But I don't know which one's which. So actually the colors are just going to be arbitrary for now. Call that one yellow, call that one blue. So this is going to be blue. Blue is going to be in one of those 2 cells. Oh, wait. This already doesn't make sense. Hold on. This is an 8 or 9, so let's say that's blue. Yellow is here. So blue is up here. Blue's here. That's yellow. Yeah, this makes more sense. I don't know what I did before. So that's yellow. That's blue. This is yellow. Oh. No, this is blue. Yellow's in one of these 2. That's blue. That's yellow. So yellow's going to be in one of those 2. Blue is going to be in one of those 2. Blue's in one of those 3. Is that the best I could do? So blue is definitely on this line. That's an interesting point. 8 or 9 is definitely on this line. It could be both. It might be too high, though. Yeah. So we might be able to get where yellow is. Because if we think that 8 and 9 both can't go on this line, then yellow can't go here. Because if yellow went here, then that would force blue to be on the line as well. And if that is already 17, that seems pretty high. Because this is 21, 20, 19, 18. And if this is yellow, then that has to be blue. And that's 17. Yeah. I don't think that could be yellow. I really don't think it can, because that forces blue here. And these are the pencil marks for yellow and blue, like officially. So putting a yellow there forces a blue there, yeah. So this can't be yellow. This is yellow. So it's 8 or 9. So yellow is in one of these 3. So we only have one height digit on this segment, which we know is 18. 1, 2, 3, 4. it's a 9, then we got to get to 9 over 4 cells. No, that doesn't make any sense. It doesn't make any sense. If we put 9 here, and we minimize this, 1, 2, 3, 4, 10 plus 9 is 19. That's too high. It has to be 18. So this must be 8. And then the rest of the digits must be 1, 2, 3, 4. I think that's right. So I think I'm going to say that this is 1, 2, 3, 4, 8. Meaning that is 9. All of the yellows are 9s. It's a bold claim, but I'm going to claim it. Ooh, that would do a lot. That would certainly do a lot. Because that would mean this is 14, and this is 15. But let's go with it, because we've gotten this far. So none of these are 8s. This is 8 for sure. So we need to pull out our alt 8. These are not 8s, so this is a 5-9 pair. Right. Gosh, I'm hitting every single wrong key here. Sorry. So Control 8, Alt 5. That's 5-9 pair. Okay. So this is 1, 2, 3, 4, 8 to get to 18. So that's cool. Using the 8s and 9s, you figure out that you have to have a high digit on the line, which restricts what this is able to be. And because 9 cannot go on it, because that would create 19 at a bare minimum, it has to be 8. That's a very interesting, cool restriction. So now 8 must be on this line. Oh, Jesus. So just like how we put one of the high digits on this line, we're putting another high digit on this line. So this is 21, this is 20, but we're putting 8 on a cell. So now we have to get 12 over 4 cells, which is pretty restrictive. It's very restrictive. And then 9 has to go in one of these 3. That's a good point as well. But the problem is it's not all going on one segment. It kind of goes on one. It could be on one segment or it could be on the other. Now, if it's on this one, first of all, let's remove these 5s. If it's on this one, then we got to get to 16. So we got to do 1 and 5 or 2 and 4. You might still be able to do that. I don't see why not. 1, 2, 3, 4, 8. Then these last digits must be 5, 7, 5, 6, 7. And 7 is pointing at those. So this is a 7. I didn't see that. I'm so sorry. How do I just place the digit? All right, there. 7 there, 7 there. Does that do anything for me? Not quite. In terms of Sudoku, I don't think it does much. Eight must go here. I think it's here. What are the ways to get to 12 over 4 cells? Well, let's see. You can never put 7 because then you'd have to do 1, 2, 3. So 6 is the highest digit you could put. It's either 1, 2, 3, 6, 5, 1, 2, 4. 1, 2, 4, 5, or 1, 2, 3, 6. I think are the only ways. So let me double check that with. There's a nice little chart that shows all this. I think it's 1, 2, 3, 6, or 1, 2, 4, 5, and those are the only ways to get to 12 over 4 cells. Yeah, I'm right. Okay, I just wanted to double check that. So either way, you have to have 1 and 2 on here as well. Oops. So 1, 2, and 8, and then the optional ones are, it's either 3, 6, or 4, 5. Okay. Okay. I don't understand how that helps me, though. How does putting 1 and 2 on it help me? 3, 6, or 4, 5. Oh, but 9s. Right, but 9s. That's the point. It's with 9s. I know 8 goes on it, so you certainly can't put 9. So that restricts 9s to these 2 cells. That's the point. Alt. Oops, no. I think it is Alt 9. Yeah, there we go. And then that's just straight up 9. That's a 5 now, so this is yellow. Let's clean that up a little bit. These cannot be 5s anymore. Oh, God. So 5s are on one of these. More importantly, we got an X-wing of 9s right here. So neither of these could be 9s. This is a 9, making it yellow. And now we could say this is indeed 15. So it's either 1, 5 or 2, 4. 2, 4 could be devastating, because that would force things to happen. Let's say it was 2, 4. Oh my gosh. I'm not trying to do multi-select. Then you'd get a 1, 3 pair right here. Oh my gosh. I need to deselect that, man. Then you get an 8 here. It would force a big chain of things to happen. Not that I'm saying it means anything, but it would force a big chain of things to happen. So yellow's in one of these two. Does that do anything for 5s as a digit? Maybe not. Where do 7s go? Right. 3, 6, or 4, 5. 7 wasn't included in that list because 8 and 7 creates 15. And then now, how do you get to 20 over 3 cells? You can't. So now 7s are restricted. So now where do 7s go? It's just a 7-9 pair. That's absurd. That must be what it is. It's just a 7-9 pair. I think that's exactly what it is. So let's do that. So now 7s are in one of... Oh gosh, I'm going between colors and numbers. Nope, Command Z. 7's either here or here. It's because multi-select was on, man. So it's in one of these 2 cells, no matter what. That is a 7-9 pair. 3, 6, 4, 5. Huh. I'm not sure what the significance is, honestly. It's going over my head a little bit. Do I have to think about this line now? This is 2019, and I can't put 9 on it anymore. 7 is in one of 3 places. 8 is in one of 3 places. No, I actually do have to consider that that's very important. And 7 and 8, 15. Could that be a 4? So they could both go on the line. I don't see why not. Yeah, I don't see why they both couldn't be on the line. What about 6s? Eh. You know, I do have to consider something. And this could be a sneaky way to see it. So we know what this is and we know what this is. So we do know what these three cells add up to, which I will label with a color. Let's make it fun. Let's do a little pink action. Those three pink cells add up to something. Now this is 15. And this is 21, 20. This is 19. So 19 plus 15 is 34. So these three do add to 11 now. Now I am going to claim it has to have a 3. And the reason why is because if I put a 3 on this line, that's a gray. If I put a 3 on this line, now I got to add to 16. But there's only one way to do that, and that's 7 and 9. But the 9's being used. And you can see the problem there. So I'm going to claim you cannot put 3 on this segment. You can't put 2 either. And you can't put 1. Right. So we're getting restrictions on that end of things. So is that creating a 1, 2, 3, 4, 5 quintuple then? 1, 2, 3, 4, 5. This 6 plus 7 plus 8 equal 19. 6 plus 7 plus 8. 15. No, that's 21. So I don't think it can be a quintuple of 1, 2, 3, 4, 5 between these 5 cells. 6, 7, 8 is... that adds to 21, and that's too much. But it's the fact that 7 and 8 must appear in these 3 cells in some way, shape, or form, which is very interesting. Right, and this is interesting because right. I'm just thinking, I know you can't put 8 here actually, because if you put 8 here, the implication is that we have to make these add to 11, and so you have to put 1 and 2, but then there's no way I can add to 6 anymore if I do that. So 8 certainly cannot go in this particular cell. So it is in one of these two. Alt 8. And the 7, it's a bit more nuanced because I believe that you could still do 1, 3 and get away with it because you could still do 2, 4 to add to 6. This would be a 7. And then these would be 8, 5, that's 13, and 6. 5, 6, 8. Question is, could 7 go with the 8? That's 15. 15. 4, that's 19. You'd have to do 1, 5, and now the digits left to get to 11 are 2, 3, and 6. So there's nothing proving that either one doesn't work at this moment. Oops, that is a 9. But we do know 8's are in one of these 2 cells, which I guess is something. And there is probable cause that there is some sort of 7, 8, 9 triple in column 7 and or 8. Just having a difficult time proving that one or the other. Right. I do know the sum of these. Oh, wow. That went over my head. I do. Placing these digits was more significant than I thought. So this is 18 plus 16 is 34. These two do add to 11. Right. 1, 2, 3, 4, 8, 7, 9. This is... okay, I'm so stupid. This was the easier way to see this. Oh, gosh. This is a 5-6 pair. And that can't be a 6. Oh my gosh. How did I not see that? That is a 6. That is a 5. So that means this cannot be 5 or 6. I feel so dumb that I didn't see that. Okay, so 6 is in one of these. 5, I'm not so sure. Oh, but 8 having to be in one of these does put an 8 here. Oh my gosh. That was also in broad daylight. So this is blue. Oh gosh, I can't figure out what I'm doing. That is blues. So that get rid of the white there, get rid of the blue there. Okay. Blue is in one of these. And blue is in one of these. So now I've sorted out all my blues and yellows. 7s I'm unsure about. Very unsure about them. So this is either 7, 6. So there's an 8 in this 3-cell 19 cage. So there's... Right. So 3 has to go in one of these. Okay, so I'm seeing an alternate, easier way to get to the conclusion that I wanted to make a second ago. Which is that 3s must go in one of these 3 cells. So can I do 3, 6, 2? That's an option. I don't know which one to think about first, this one or this one. Maybe I could do the blue line since I just can make that easier. Or I could do the segment since that's part of the rule set. So 8 must go on the 19 line. So what are the ways? It's like I need to write this down because my stupid brain, my little brain can't handle this. So you can't do 8, 3 to get to 11 anymore. You can't do 9, 2. So it's 4, 7 or 5, 6. 4, 7 or 5, 6. 4, 7. Would get you that. This would be 2, 3, 6, which definitely works. I need to take away these 7s. They're tripping me up. Yeah, this is all very confusing to me. I don't know if that's the place to look anymore. Because I do have probably better sources of information going for me that I'm just not seeing. It could have to do with this cage. I mean, something is telling me that the 7s could have gotten placed in box 7 already, but I don't think I could do anything with that little killer yet. You know? In this, I don't know if it's... gosh, it was the 4-cell 12 segment. 1, 2, 3, 6... or 1, 2, 4, 5. Yeah. Fives in one of these 2 spots. This is such a silly pencil mark, but it's true. Yeah, it's something simple that I'm not understanding here. Hmm. Definitely stuck now. It's got to be this 6 cage, right? Yeah, the 7 can only go in 2 places in this row. There's just something trying to tell me that this can't be 2-4. I don't know why, but it's because it forces this to be 1-3. And then 5-7. I just don't know if there's a problem with that. I don't think there is. Is there a problem with using 1-5? Oh no, it's simple. Let me think about it though. Might be this cell. Can you put a 6 here? And you might not be able to, because if you do, you get 6, 8. That's 14. And you got to put a 5 to get to 19. Oh my gosh. It's that simple. We did this earlier in the other boxes where we just picked a digit, said, well, it actually can't be that one because it forces an impossible scenario. It's very simple, but I don't think it could be a 6. Yeah, 6, 8, 14. That forces a 5. That's 19. So that can't be 6. That is exactly what that's saying. So now it must have 3 and 6. So that's 9. So it must be 2, 3, 6. Wow. All right, that's something. That's one way to figure it out. That can't be 6, obviously. So now this can't be 2, 4. It is 1, 5. Oops. Command Z. Z. It can't be 1. That can't be 5. So now this is 5 for sure. Big boy 5. 1, 2, 3, 4, 5, and then 7. This is a 7. It's the only digit we haven't placed. So that's a 7. This is a 6. So that means that's a 4 according to the killer. So now we can get rid of all of these 4s. That can't be 4. Neither of these could be 6s. So I don't know if 6 is restricted enough. We do know this one. This is 4, 8. That's 12, and then 7. So this did end up being a 7, 8 pair. Huh. That's interesting. Oops. 7, 8. So that is a 4. Which gives us 4 in one of these 2 cells. Oops. Alt 4. That can't be 4. These 2 can't be 4. This is a naked 7, 8 pair, making this a 9. So that is yellow. I can't believe I just didn't look at that one cell and just thought if it could have been a 6 or not. But in hindsight, it was very obvious. That is a 7. That's a 7. That's a 7. That's an 8. That's an 8. So there go my blues. So these can't be blue. This is the 8. So either of those can be 8. Oops. I'm just trying to clean some things up, man. So that puts my 9 here. That's the last yellow. So this is a 5, which means that's a 5. 5's in one of these two. That's a 1. It's a 1. Cannot go in one of those two. That can't be 1. How are 6s doing? Well, actually, 4s are in one of these two. So neither of these could be 4s, so that makes this a 4. So neither of those could be 4s. And then the pencil marked 4s get rid of this 4 and that 4. So now, with our powers combined, we could get a 4 there. Just doing some simple Sudoku. So we do know this is either 1, 2, 3, 6 or 1, 2, 4, 5. And 4 has to go on the line. So it is 1, 2, 4, 5. Yeah. So this cannot be 5. This is the 5. This is 1, 2, 4. The 1's looking at those cells, so that's a 1. 4 is looking at this cell, so that's the 4. That's the 2. So that can't be 1. These can't be 5, so this is the 5. So 1, 2, 3 triple, that's a 6. That can't be 2. That can't be 2 or 4. Those can't be 1s. So 1s are in one of these. Twos are in one of these. This is a pair. This looks like a 3-6 pair. It's like a 2, 3, 6 triple, so that, in other words, is a 1, 4 pair that I did not see. Three, 6, that's a 1 then. This is a 2, 3 pair. We're missing 1, 2, 3, and 4. Okay. What am I missing here? I guess you could use simple Sudoku with 5s. That's a 5. So now we're done with 5s. 1s. Maybe not yet. What about 2s? Can we do anything? We don't have many 2s on the board. 4s maybe? Surprisingly not. Just finished 5s, about 6s. 6s are in one of these two. Oops. 7s are done. So what's the secret here? It's this. It's this. This is where this comes in, finally. Because I just was thinking, like, how am I supposed to solve this? So this is, we have 7, 8. We have 7 and 2 9s. So that's 18 plus 7. That's 25. So these two need to add to 5. So that can't be 6. This is a 3. That's a 2. Wow, so that's a 2. That is a 6. That's a 1. That's a 2. That's a 3. That breaks wonderfully. This is a 1. That's a 4. That's a 1. That's a 4. So that's a 4. That's a 4. That's a 1. So the killer rule just kind of helps you finish the... oops, the puzzle. This is a 2, 3 situation. So is that. So looks like a naked 1 in column 5. That's a 3. It's a 3. Those are 2s. Just finishing this thing up here. This is a 6, 1 pair. That's a 1. That's a 6. That's a 6. That's a 2. That's a 2. That's a 3. And that's a 3. Wow. That was a fun one. I actually enjoyed that. It was challenging. It took me longer than it should have. Mainly because I got stuck here. Just this area. Just realizing that that can't be a 6 because 8 is forced on the line. So if I put 6 here and I put 8 here, it forces 5, and 5 was already in row 5, so that couldn't have been possible. Really good puzzle. I like the way it finished, using that 30 diagonal killer cage to help out. But yeah, I hope you guys enjoyed today's walkthrough of today's puzzle, and I will see you guys next time. Bye-bye.